All right, so here's the answer key to the test review. So these ones we're just going to factor. And if you've forgotten about the x method, remember we have this formula here, ax squared plus bx plus c. That's our standard form of a quadratic function. When you do the x method, remember the b goes at the top. You divide both sides by a, and then to figure out on the bottom, it's a times c. And you're going to have two numbers that are called factors. And those two numbers have to add up to b, but multiply to a times c. All right, so for the first one here, first off, go through the factoring steps. It is in standard form. There is no GCF, and there are no special cases. So we identify that a is 1, b is -9, and c is 20. So for the x method, -9 at the top, we divide by a, which is 1. Then we multiply a times c, which we get 20. So two numbers that add to -9 but multiply to 20 are going to be -5 and -4. So when I reduce this reduces to -5, so x minus 5 reduces to -4, so x minus 4. Notice it does not say to solve, so my factored form is in parentheses, and that's done there. All right, for the next one, it's going to be the same steps. Standard form, no GCF, not a special case. So let's go and identify a, b, and c. X method. So b at the top, divide by a, multiply a times c. Figure out your numbers or your factors that add to 4 but multiply to -32. Let's go with 8 minus 4. So 8 minus 4, so 8 minus 4 is 4. 8 times -4 is -32. When we're divided by 1, it's the number, so 8 divided by 1 is 8. And -4 divided by 1 is -4. So we have x plus 8, x minus 4. All right, this next one, first off, it's in standard form. There is no GCF, but this is one of those special cases where you have a squared minus b squared equals a plus b, a minus b. So we're going to take the square root. The square root of this is x. The square root of this is 5. We write it twice. One's positive and one's negative. And once again, you can use the x method. Remember, your b value would be 0. All right, for number 4, it says to solve for numbers 4 through 6. So here, it's already set equal to 0. It's in standard form. No GCF, no special cases. So we identify, again, a is 1, b is 1, and c is -6. So x method, 1 at the top, divide by a, which is 1, and then 1 times -6. So the two numbers that add to 1 but multiply to -6 are going to be 3 minus 2. So we have x plus 3, x minus 2 equals 0. So this is my factored form. And then I set each one equal to 0. So my solutions, this would be x equals -3 and x equals +2. Because remember, the directions do say to solve. All right, for the following problem, first off, notice it does not equal 0, so we're going to add the 4 to the other side. All right, it's in standard form, no greatest common factor, and this actually looks like a special case, right? This is a perfect square, and this is a perfect square. You can also do the x method, but I see the perfect squares, so I take the square root of this, which is x, the square root of this, which is 2. So x times 2 is 2x, double it is 4x, so we use the middle symbol, and we square it. All right, so we do have x minus 2 squared is equal to 0, so this is my factored form. Remember, since it's squared, that means there's 2 of them. So once you set just one equal to 0 and you solve it, x is equal to 2. All right, for number 6, hopefully you see that this is one of those special cases as well. So this is a difference of 2 squares, just like this one. So square root of this is x, square root of this is 6. Once again, one's positive, one's negative. It does not matter which one you choose. Set each factor equal to 0. Remember, in order to be set equal to 0, it does have to have the variable x. So if I subtract 6 here, x equals -6. Add 6 here, x equals +6. All right, on to numbers 7, 8, and 9. For number 7, finding the zeros is the same thing as solving. So we're going to now change this set equal to 0. So x squared minus 12x plus 32 is equal to 0. We look for it's standard form, we look for a greatest common factor or special cases, which you don't. So now we're going to identify A, B, and C. X method, negative 12 on the top, dividing by 1, and then 1 times 32 is 32. So my two factors that would add to negative 12 but multiply to 32 is going to be negative 8 and negative 4. So we have x minus 8 times x minus 4 is equal to 0. Set each one equal to 0. So x equals 8 and x equals 4. Those are my two solutions. All right, on to the next one. Now this one here, hopefully you see that it's missing the c value, right? It's in standard form. Well, let's make set equal to 0. But it's in standard form, a, b, there's no c. This is whenever you're missing the c value, there's always a greatest common factor. The greatest common factor is going to be the variable in this case, right? Because they have x in common. When you factor out the x, you're left with x minus 6. And now we know it's completely factored because these are prime factors. Nothing else can be simplified. So now we set each one equal to 0. The first one is solved. If it had a coefficient, you would divide it and you would still get 0. For this one, you're going to add the 6 to the other side, and you should come up with x is equal to 6. All right, on to number 9. For number 9, it's kind of the same concept. You're going to first set it equal to 0. GCF here is just negative 3. So leaving me with x squared, and negative 3 times negative 4 is positive 12. Notice this is a difference of two squares. So x squared of 4 is 2. And one's positive and one's negative. Last, when we set equal to 0, we can only set factors that have x equal to 0. So x plus 2 can be set equal to 0. And x minus 2. The reason why this negative 3 cannot, because it does not have a variable of x. So my solutions are going to be x equals negative 2 and x equals positive 2. All right, on to number 10. So number 10 is a word problem. And this would be like a good example of like an open-ended question I would definitely ask. It says you are making a square frame of uniform width for a square picture that has side lengths of 2 feet. So here's the picture with side lengths of 2 feet and a frame with the length and width of x. The total area of the frame is 5 square feet. What is the length of the sides of the frame? Okay, so given the fact that we're given the frame is 5 square feet and we want to know the length of the side, how we could do this is, to figure this out, we could use area, right? So to find the area of the total area, using what they've given us, we can say x times x. And then we're going to subtract the inner area. The inside area is going to be this dimensions of 2 by 2, so 2 times 2. And we already know the total area, which is 5 square feet. Okay. Now, from here, x times x is x squared. 2 times 2 is 4, and equals 5. So in order to solve this quadratic function, it's quadratic because it's squared, we're going to subtract 5 to the other side and set it equal to 0. And then we come up with a quadratic function that is a difference of two squares. So it is a special case, right? So the square root of this is x. The square root of 9 is 3. 1 positive, 1 negative. Set each one equal to 0. First one, x equals negative 3, which we cannot use. Second one, x equals 3 feet, which we can use, because if you plug negative 3 in here, you can't have negative length and width, but with a 3 you can have, right? So our answer is x is equal to 3 feet. All right, now we're on to number 11, and once again, number 11 is an excellent choice for an open-ended question as well. So it says the dimensions of the old stage at the concert hall were 30 feet wide and 15 feet deep. The new stage has a total area of 1,000 square feet. The dimensions of the new stage were created by adding the same distance x to the width and the length, or the depth of the old stage dimensions. What is the value of x? So we do have a rectangle, right? 30 feet by 15. And they said it's going to equal a total area of 1,000 square feet, and they did this by adding the same distance x to the width and the depth. So we're going to add x here and add x here. So to find the area, we multiply it. So 30 plus x times 15 plus x is going to equal 1,000 square feet. Okay, I'm going to FOIL this out. So 30 times 15 is 450. 30 times x is 30x. X times 15 is 15x. And x times x is x squared. I'm going to rearrange this so it's in standard form. So x squared plus 45x plus 450 equals 1,000. And hopefully by now you know in order to solve a quadratic function it has to equal 0. So we're going to take away this 1,000 from both sides and subtract it appropriately. So we come up with x squared plus 45x minus 550 is equal to 0. Now we perform the x method. So 45 on the top because this is b. A is 1 and a times c, so 1 times negative 550 is negative 550. Factors that add to 45 but multiply to negative 550 are going to be 55 minus 10. Okay. So from here we get x plus 55, x minus 10 equals 0. Set each factor equal to 0. So x equals negative 55, which I can tell right now by plugging it in would not yield positive, so that's not going to work. And the last one, x equals 10 feet, is going to be my solution because 30 plus 10 is 40 and 15 plus 10 is 25, so that's going to work out nicely. All right, for numbers 12, 13, and 14, it says to factor the expression. So I'm not solving, I'm just factoring. So notice now the a value is not 1. So it's in standard form. There is no GCF. There's no special cases. So let's identify a is 3, b is 10, and c is negative 8. So b at the top, divide by a, which is 3. And then 3 times negative 8 is negative 24. So my factors would be 12 minus 2. 12 minus 2 is 10. 12 times negative 2 is negative 24. 12 divided by 3 can reduce to 4. So that's going to be x plus 4. Negative 2/3 cannot reduce or simplify, so the 3 is going to go in front of the x. So that's going to be 3x minus 2. All right, on to number 13. So for number 13, notice there is no b value. There's no bx. So first off, standard form, yes. Is there a greatest common factor? Yeah, 18 and 2 are both divisible by 2. And hopefully you see right here, this is a difference of 2 squares, right? There's 2 factors that are both perfect, or 2 terms that are both perfect squares, and there's a minus sign. So the square root of 9x squared is 3x. The square root of 1 is 1. 1's positive and 1's negative. If you want to double check it, you can always just FOIL it out, and it should come back exactly to that answer there. And then when you finish it, it'll equal that. And then for the last problem for this set, it says 9x squared plus 12x plus 4. So there is no GCF. It's in standard form. It is one of those special ones. I see right here this is a perfect square. This right here is a perfect square. So before we go further, we multiply it. 3x times 2 is 6x. If you double it, it does give you 12. Use the middle symbol and square it. If you choose to use the x method, just make sure you are reducing your factors with the denominator. All right, we're down to our last several problems here. So it says to solve the equation. That's why they're set equal to 0, to remember to solve. All right, so for this first one here, 9x squared minus 4 equals 0. First thing I notice is perfect square, and a minus sign. So the square root of 9x squared is 3x. The square root of 4 is 2. 1 positive, 1 negative. And you can always double check this by multiplying it back out. Now it's completely factored, so we set each one equal to 0. So for this one, I would subtract 2, divide by 3, and x equals negative 2/3. The other one, you would add 2, divide by 3, and x equals 2/3. So notice these answers, whenever you get like a difference 2 squares, they're always going to be the same, but opposite signs. So negative 2/3 and positive 2/3. For the next one, standard form, yes. GCF, no. Is it a special case? Not a perfect. Yeah, once it's not a perfect, you move on to the X method. So we're going to identify A, B, and C. X method. B at the top, which is negative 6. Divide by A, which is 8. And then 8 times 1 is 8. So two factors that add to negative 6 but multiply to 8 are going to be negative 4 and positive 2. This reduces to negative 1/2. This reduces to 1/4. So we're going to have 2x minus 1 and 4x plus 1. So 2x minus 1 equals 0, so add the 1. 2x equals 1, divide by 2, x equals 1/2. For the other one, 4x plus 1 equals 0, subtract the 1. 4x equals negative 1, divide by 4, x equals negative 1/4. So those are your two solutions. All right, for number 17, first off, it doesn't equal 0, so we're going to move things over to the same side as the squared term. So I'm going to add 10x. At the same time, I'm also going to subtract 8, so just so I'm doing this in one step and not taking up too much room. So 9x squared plus 21x plus 10 is equal to 0. So it is in standard form. There is no greatest common factor. So we can do A, B, and C. X method, 21, divide by 9, and 9 times 10 is 90. Let me see, this 21. All right, so here I'm just going to use a calculator to get these factors real quick. There you go. So you have 6 and 15, because 6 plus 15 is 21, and 6 times 15 is 90. This can be reduced to 2/3. This can be reduced to 15 over 9 reduces to 5/3. And here, instead of writing it as a factor, I'm going to go straight to the solution. So we talked about this before. So the opposite of 2/3 is negative 2/3, and the opposite of 5/3 is negative 5/3. And once again, you can also set that equal to 0, each factor. So this would be like 2x plus 3, 5x plus 3, set them equal to 0, and solve. Okay. All right, for number 18, once again, has to equal 0. I like to keep my squared term positive, so I'm going to add 3x squared to the other side and subtract 6x. Here, I notice they do have a GCF of 2. I'm not going to identify A, B, and C just because of space, but as you can see, B is negative 4, A is 4, and then 4 times negative 3 is negative 12. So my factors would be negative 6 and positive 2. So 2/4 reduces to 1/2. Negative 6/4 reduces to negative 3/2. So if I were to write this as a factor, it would be 2 parentheses 2x minus 3 and 2x plus 1, set equal to 0. Now you can set each one equal to 0 and solve it, but remember this does not have an x, so this does not have a solution. We should only have 2 solutions. So for me, I'm just going to write the opposite. So the opposite of negative 3/2 is positive 3/2, and the opposite of 1/2 is negative 1/2. And those are my solutions. All right, on to 19. Once again, move everything to the same side. So we have 7x squared minus 3x. This cancels out, equals 0. Here we have a common factor of x. So x times 7x is 7x squared. X times negative 3 is this one. So this is the one where I do set them equal to 0. The first one is done. The second one you would add 3 to both sides, and then divide by 7, and x equals 3 over 7, or 3/7. Alright, down to the last two problems here. It says to find the value of x given the area of a triangle and the area of a rectangle. So for these here, so hopefully you know the area is base times height divided by 2, or half of the base times the height. Whichever one you choose to use, it's fine. Okay, so we have a base times height, so 4x plus 1 times 3x divided by 2 is equal to 27. I'm going to multiply both sides by this 2. And so we have 4x plus 1 times 3x is equal to 54. So distribute this, 12x squared plus 3x equals 54. Last, we're going to subtract this 54 over. Hopefully you can see, let's double check this. Let's see if they're all divisible by 3 or not. So I'll just take 54 divided by 3. And they are, right? So I can factor out a 3. So let's change the color here. So we're going to factor out a 3. 3 times 4x squared is 12x squared. 3 times 1x. And 3 times negative 18. Alright, so from here, x method, 1, divide by your a value of 4. And then 4 times 18 is negative 72. So this is going to be 7 and 6. I don't think that's right. 7 and 8, sorry. 7 and 8. No. 9 times 8, sorry. 9 times 8 is 72. And then this one would be negative. So 9/4 is going to be, opposite of that is negative 9/4. And this one reduces to negative 2, and the opposite of that is 2. So hopefully you see your solution is going to be x equals to 2. For the last one, I'm going to set it up, but I'm not going to solve it for y'all. So here's what it would look like. It would be 3x plus 1 times 2x plus 1 is equal to 22. You can FOIL it out. I guess I can have a little bit of time to work this out. So I'm just FOILing it out right now. Let's go ahead and combine our like terms. Subtract our 22 over. And then from here you would do the x method. So I'll set this part up for you. But I probably won't solve it unless I can do it real quick. Let's see. This gives me 126. Alright, and from here you would have to figure out these factors here. So I'm going to start with the big number here. Let's see. I don't know. Let's start with 5, which is not going to work. 6. 6 and 21 is 15, so 8. Whoops. Alright, there it is, 9 and 14. So we're going to take away 9. And then we can reduce this to negative 3/2. We can reduce this to 7 over 3. So my solutions are x equals negative 7/3, which is not the answer. And the opposite of negative 3/2 is 3/2. This is my solution here. Alright guys, that's the answer.